Hello everyone, today I'll show how to make a microcontroller behave as a USB device. USB is a very flexible protocol with many standard types defined such as keyboards, mice, game controllers, mass storage devices, webcams, audio and serial devices and many more. So I will be showing only two of them, others should be very similar. I will be showing serial terminal and keyboard. So let's start. First of all, I am using a larger chip today. It has more flash and more RAM and higher speed clocks, but I expect any STM32 device to work similar with some difference in initialization and pin setup. The other thing that I use as a starter point is a Blinky program. I expect that you would have something similar for any board that you bring up. In my case, this is a Blinky that will blink 3 times fast and 3 times slow, and I can validate that this is actually runnable by using cargo run, and I expect the LED to flash. So I take a look at the device. If the LED flashes, everything works, and I also see terminal output, which means I can capture output if I need any debugging. So let's get started. So my goal is to figure out how to create a USB device. So I will do cargo search, and I will search for USB, and I need embedded devices. And this gives me two results. It gives me a human interface device, so HID, which is keyboard, mice, and so on, and it gives me a generic USB device. The other thing I noticed is that USB human interface device reference USB device. So my assumption now is that USB device is the main library. And if I actually only look for USB device, it gives me lots of hits, and this actually does tell me that indeed I could do audio, I could do human interface device, I could do serial console, and so on. So great, this is the library that I want to use, and let's get started. I will go into Createio and search for USB device and read a little bit of documentation. One of the interesting bits is that there is an STM32 USB device driver implementation crate, so I will be using this as well. If I go to the human interface device library, I see that it does have some examples, but I don't see any additional details of dependencies. The one part that I see is that it supports Raspberry Pi and it was tested on it. However, I use an STM device, so this means I may need to do a bit of extra work. I know I need to do extra work for this to run on my microcontroller. Finally, I'm using a hardware abstraction layer for my STM32F4. And for this, I generally go into repository and examples, because after the examples show all the functionality that the microcontroller supports in some easy to read code. And in this case, I am reasonably lucky because I see there is an USB serial example. So what I would like to do is let's copy this and see if I can make this work. So I will copy this code and let's create a new example, and I will call this USB serial. And let's paste everything into it. This is pasted, but it will say that some things are not known because it uses USB serial and device builder and so on. We did not include the crates. So let's go through the crates. The crates that I am using are USB device, human interface device, and I remember that I need the STM32 device driver and the USB-D serial because these are the tests. Another thing that I had to do was make sure that the full speed USB device is added as a feature for my hardware abstraction layer. So I have serial.rs, I will save it, and let's see if I have any errors or any complaints. It complains about panic halt because my main has a different panic. Let's copy it from there, from my Blinky example. Now that I have the imports, let's initialize the Println as well. I have USB serial started. Let's try to run it. So I'll do cargo run and with the example. USB serial started, so it's doing something. Let's try it out. So ls USB. I don't see any specific name in here, although from the configuration it should be, say a fake company and product serial port and the serial number test. However, what I can do, I can check to see that my serial device monitor shows up that the USB is plugged and unplugged when the program starts up. So let's do this. udev admin monitor, and I will stop the example and start it again. And what you'd notice is that a new device, well, it disappears when I stop the example, and the new device appears when I start the example. The next part that I read is what does this do? And I see that it will poll the data and it will read whatever data is received over the serial number, and then it will output in uppercase. So I expect that I should be able to type in this TTYACM 0, and everything I type should become uppercase. So let's try that. Let's use minicom on TTYACM 0. And notice I write test 1, 2, 3, and everything is uppercase. Next, since I have some sort of an output, I would like to see if I can capture the data. So I can see that this serial, this reads into a data buffer. So I would like to read in the same data buffer. I would like to convert it to UTF-8 and actually output it to the screen so I can validate what I found. So once I read OK count, I will convert from UTF-8, and this may fail if the UTF-8 data is invalid. I have a conversion from UTF-8. In case of an error, I will say it's not a valid UTF-8, and in case of success, I say I received this value. Let's try this out. In another terminal, I will say minicom, and let's write test. So what I see is that I receive the items one by one. I receive them uppercase because I typed with shift pressed. Let's write lowercase. So you see the output is still uppercase, however receiving, interesting enough, still uppercase. Oh, because I do it after the conversion. So let's move this before. That's strange. USB serial has started, and I am opening minicom, and I will try to write test again. I see output uppercase, but the input data was lowercase. But it does come character by character. So let's see, let's do some additional tests. What happens if I say send something invalid? And what happens if I write multiple things? So I will be using Python for this. So let's write A0, which is invalid UTF-8. Let's see what happens. And I will see, I will try to convert it and says invalid UTF sequence. Great. And let's write multiple items. Test 1, 2, 3, 4, something. And I received the entire test, but I didn't check the output, but the output should be uppercase. Excellent. At this point, we have a serial implementation. So let's go ahead and create a keyboard. So I will use this serial, and I will use it as a starting point. We named this USB human interface device, and it's using similar code. However, what I will do this time is I will get the example from the human interface example, this bit, and let's try it out. We already have a USB. We all need the keyboard, and we need the loop. I'll go past the USB initialization. I will delete the serial implementation. This should be it, except I have extra braces. Great. And I see that it doesn't know what some classes are. Let's quickly import everything that is needed. At this point, I am trying to see what is missing. So one, it's missing the clock. USB is USB bus. That one is not actually missing. It doesn't know what a pin is, which is the button pressed. And it doesn't know what update LEDs are. Let's fix these the easy way. The first one, instead of update LEDs, how about I just print out things? The printout should be just a debug version. What I expect this to tell me is that if it's caps lock or num lock or things like that are enabled. The next part would be, let's figure out a pin number. I know that my button is tied to A0, so let's create a pin based out of A0. We have a pin that is an input, so when I press it, it should tell me whether it's high and low, and in this case, for STM32, for the version that I have, there's no need for unwrap. This cannot fail. I also need to import keyboard. And the only remaining bit is clock. So let's figure out what this clock is. I went to the USB human interface documentation, and let's find default config. The default config tells me that I use some sort of a clock when I create it. Let's find information about this. and it seems to be an embedded time clock. So first of all, I will add this library embedded time, and it seems that I need to implement, basically get the current time. Interestingly enough, new timer is already implemented. So as long as I implement current time, everything should be fine. So let's go through it. I added embedded time. I will need some form of a current instant time. It needs to tell me that's a scaling factor, like how much of a second every unit of this time is, and I need to return the current time. So what I would like to do at this point is to have a millisecond resolution timer. So I would use the STM32 to tell me issue an interrupt every 1 millisecond, and I will have a global counter to count the current milliseconds. I create a global atomic UN32 that says these are the milliseconds, and I expect this to be updated in an interrupt. So let's use interrupt 2. At this point, we have an interrupt and we have a global milliseconds that will get updated each time timer 2 fires. I would like to debug this to see if we have an actual working timer. So I will at first make it fire every 1 second, and let's print out something. This will print it out, and I also have a to-do because once the timer flag is set in the microcontroller, unless I reset it, it will keep on firing. So we'll have to have some sort of a way to reset the timer. So let's go and implement things. At this point, I created a counter, and I created a counter that counts down in milliseconds with a timeout of 1 second, and I would listen for the update. If I am looking at documentation, let's look at STM32 documentation for counters. Here are the counters that could be created. I can see that these counters are created from a specific timer extension. And it will say that I can create a millisecond counter that works between 2 milliseconds and 65 seconds. And then the microsecond one has more precision, and it can count smaller intervals, but it cannot go too high. So for me, I want to count every 1 second, and this is the range that seems to make sense. Let's start and see, because I did not finish my to-do of resetting the timer. I expect this to go kind of like a very fast loop. And the other thing is my code doesn't yet compile because I did not yet define clocks. So let's comment out these things. I commented out the actual implementation, and I just say loop forever waiting for interrupts. Let's run this. Atomic 32 default doesn't work, so let's create a new one with value 0. Apparently my probe is broken. Let's fix that really quick. After a bit of debugging, it turns out that having a loop that just does assembly, wait for interrupts, will not work very well. It crashes my device for whatever reason. So I made a loop that just goes tick and talk, and everything compiles now. So what I have is I have my timer and my slide timer, and I println wherever I receive the event. And because my configuration is every 1 second, I expect to have a 1 second timer. What happens in practice, however, is that I have a lot of immediate retries, and you will see that the timer just keeps on increasing as fast as possible. And this is because I do not reset my timer. So what I need to do is keep a reference to my timer and my counter and reset it. Let's do that. This complex thing is that I need a counter, and it's optional because it's only available in main, and I need to change it once it's available in main. So I put it inside the ref cell, and then everything has to be protected, so everything is in the mutex. So the full type is mutex that contains a ref cell, that contains an option, that contains a counter for my timer 2. In practice, this means I need a reference to timer 2 so I can reset it. This is how one resets the timer. I interrupt free so I can access the mutex, and in order for me to access the mutex, I will try to borrow it so it's not none, and then I will clear existing interrupts. Let's fix the imports. interrupts are fixed. And right now this will be initialized with none. So somewhere in main, I actually have to set a global timer. Let's do that as well. I will do the interrupt 3-bit because I need to access the mutex. And I'll say borrow the mutable version of the reference cell and place the timer inside that global timer so it can be reset. At this point, what I expect is that actually 1 second does take effect. Let's try it out. My counter types are not right because I am using ms versus microseconds. After fixing it, I get an error that says that I need to use deref mutable for this method to be available. I can do that. Let's run it again. Notice that my main loop started, however my counter did not take effect. Let's see why. It doesn't work probably because I didn't print it out. So let's try to print it out again. And I want to get the current time very frequently. So let's implement a function for the current value of the counter. This will return the current counter as a U32. Let's print it out. And I should be able to run it and see the counter running. You can see the time interrupt occurring every 1 second, and I have the tick and talk that's in the main loop. So they run interleaved. Excellent. I can move on to milliseconds. The changes are that the counter is now in microseconds, so I can measure such small intervals, and I start every 1 millisecond and I listen. So now I have the ability to get the current time in milliseconds. So let's implement a fake clock that is suitable to initialize the USB peripheral. The fake clock doesn't do much. It's just an empty structure that serves as a placeholder because I will access global data. Let's implement a clock for fake clock and fix some imports. Now that imports are fixed, let's go through the code. I say that the type of the clock is a U32 because this is my counter, and it runs every 1 millisecond, so every 1/1000 seconds. And when it tries to get a current value, I just return the global counter value. So at this point, I expect that I can take out this code, and the USB device should actually work as long as my clock is one instance of a fake clock. Let's do that. And let's try to run the example. It panicked. Let's see what it said. It tells me that the builder fails when it borrows the interface. So I'm guessing it's some sort of an ordering. So let's move the USB device creation to be at the end. And try again. This works okayish, except it tells me that, well, at least it goes further, but it tells me that result unwrap, it would block. Let's see where it would block. It's at line 131. Now looking at this loop, this thing loops as fast as possible. And what it does, it tries to write a report and it tries to advance some sort of a state machine, and both of them are using unwrap. I'll switch them to OK. This is still not perfect because the way USB works is it's controlled by the host. So we are the device, and the host periodically asks us, please give me the latest report. So us looping as fast as possible and trying to write a report is not ideal and will fill buffer. So I expect these will eventually say would block because we cannot, the MCU runs faster than the host will request data. So we'll have to have some sort of throttling here. For now, I'll just remove the unwrap, and I want to see if it advances further and if I can see an input device showing up on my Linux machine. So I moved the unwrap to OK, and let's run it again. I see that the keyboard LEDs report shows up, and this is what I expected: num lock, caps lock, scroll lock, and so on. So let's do the udev admin monitor and see what happens when I restart the device. Does a keyboard show up? USB serial started, and you can see that I have an input showing up. So what this means to me is I believe that I am showing up a keyboard. So what we should do right now is implement functionality and actually not use this kind of an OK. While looking through the examples, what I saw is that there usually is a throttle, and the way it works is the tick happens every 1 millisecond and the report every 10 milliseconds. Let's implement this sort of a throttler. So I would like to not send ticks and reports faster than this rate. So in my throttler, I will say this is where I receive my last tick, and this is when I send my last report, and I will not allow it to go faster than my set deadlines. When I create a throttle, I just assume I sent everything as of today. I could start it with 0, but should be similar. And let's implement two methods. One would be should I tick, and one would be should I do the report that will check for timeouts. This is the implementation. If I should tick, it gets the current time, and if current time is not past 1 second, then just say I should not tick, otherwise say yes, and update the last tick time. And the same for report, except I use 10 milliseconds. And this should be configurable, but for now I hardcode everything because this should be simple enough. Going into main, I should use a throttler. A new throttler was created, and let's use it to determine whether I want to write a report or I want to tick. This is using the throttler, and I expect it would work. I'm not that happy though with this kind of casting of OK. So what I would rather do in here is let's add some error handling. This is the error handling. So I try to do the action, like in this case, write report or tick, and I check if it's okay, everything can continue, there are no errors. And then if it would block, I think this is expected. And also duplicate, I think is expected, because if I don't press my button, I will keep on sending no event. And if I press the button, I will keep sending A. So I expect the same event to be sent over and over again. I will not change it every 10 milliseconds. And anything else I want to actually be reported. And then for tick, I expect that tick may block in case we are not polled by the OS so frequently, but other than that, any error should be reported. Let's run this. USB serial started, and I switch to the terminal, and let's press the button. Notice how A is printed, which is what I would expect from my fake keyboard. Because my fake keyboard says when I press the button, pretend that an A was pressed. That was it. I hope this was interesting or useful or both. Have a great day. Thank you.